today we are going to discuss the sorting method count sort. So let's start. So before digging ourselves into the working of the algorithm, let us discuss the time and the space complexity of the algorithm. So here we go. The worst time complexity of the algorithm is O(n plus k, where n is the number of elements present in the array and k is the maximum element of the array. So if an element has 10 elements and the maximum element of the array is 40, so yeah, n is 10 and k is 40, like that. The space complexity here is O(n plus k, because of the reason that we would be taking an auxiliary array of the size of the maximum element of the array. So like the size of the array would be like 40, as we have taken the example previous one. Now why do we use this? As many other sorting methods like merge sort and quick sort has a time complexity of O(n log n and the space complexity of O(n). So they are better than this one. So why do we use this sorting algorithm? So let us discuss that. So for an instance, let us take an array where we will be doing the working steps also, and we will be explaining why do we use this sorting method in today's date. So here is our sample array, and as from the first glimpse of yourself, you can see that there are repetitive elements in the whole array. So here is the first point. So counting sort has a benefit over an array which has repetitive elements in it. The more the repetitive elements would be present in that array, the more benefit we would be getting in our count sort. So here, as you can see, 2 is repetitive, as 2 is coming 3 times and 6 is coming 2 times, and like that. So here first of all we have to take an auxiliary array of size 8, as the maximum element here is 8, and we have also discussed this fact that we would be taking an auxiliary array of maximum element in this whole sorting method. So here we go. The range of the elements and the index, you can say, is from 0 to 8, so the total size of the array is like 9. Now what will be the values present in the indexes? So first of all you have to assign all of them 0 as for now, so that they don't pick up any type of random values, and let us see how it works. So here we are doing like that if an element is 2, for an instance we are taking 2, so we are putting the occurrence of 2 on the index. Like here the array is like that and the index 2 is this one, so we are putting the occurrence here in the value of the index. So here 2 is repeating 1, 2 and 3 times, so here we go 3. Just like that, you see 0 is only once coming in the whole array, so here we go 1, and 1 is also coming for once only, and you can't see 1 in any other element, so here 1 is also 1. Like that you go for 6, 7 and 8. 8 is one time repeated, 4 is not present here, so we go it as 0, like that. Now our second step. So in our second step we would be doing the sum of the previous occurrences. So let me explain it in simple method. So we are doing like this, that here the first index has a value of 1, right, and the second index has a value of 1. I am saying like that for 0 index has a value of 1 and first index has a value of 1, like that. So we are doing the sum up of the previous indexes, like we are doing the sum up of like 0. For an instance we are taking 0 and we are putting the value, so 0 has no previous index, so it is 1. Then we are doing for 1, so here we are doing 0 index value plus 1th index value, so 1 plus 1 2, like that. And then we are adding 1 plus 1 plus 3, like that for 2, so here we go 5s. So like that we are keep on adding, so here it is, so 1 plus 1 2 here, then 5, then 6, then 6, then 8, then 9, 10, 11. So I guess you have got it, that how we got it. So you have to just sum up the whole elements that are previous to that index and just do the sum up. So you can just use a for loop for this purpose and go on adding the indexes as you will be proceeding. Now here we have the index. Here we have come into a step where we need all the indexes that we have done in the previous steps. So here is the arrays that we had in the previous time. As you can see, the auxiliary array we can call it, and the array that we had originally, we need that for now. So this is our original one and this is our auxiliary one. So here the calculation is little bit complicated, but I would try to make it easier for you guys. So it goes like that for an instance, let us take 8 here in the main original array. So let us pick 8. So now you will go to the 8 index. So the value present in that index, you have to go to that index in the auxiliary array. So here we go to 8 and then you find the value of 8 is 11. So you will go and put 8 in the 11th index and decrement it to 10. So here it is now 10. Then we will be doing to 6. Our working with 8 is done. So we have moved to ourselves to 6. So here 6 has a value of 10, right? So we go into the 10th index and just put it. Sorry, it is little bit not proceeding. So it is more like that, the 8, 11, 7, 10. So here 7, 10. So then here we go 5. 5 has a value of 8, like that. It is actually little bit not correctly arranged. So you can just think it like that. 8 has a, on the 8 index you find 11, 7th index 10, 6 index 9, 5 index 8, like that it's actually. So here it is 8. So 8 index has 5, decrement it to 7. Then you can see here again 5 is coming. I am jumping a bit so that you can understand it better. So here again we will go to 5 index and here we can see now it is 7, right? So you will put the value to 7th index. Like that you will decrement and go on and you will find the sorted array here. So yeah, this is what we do in sorting algorithm count sort. I hope you all have understood it. Thanks for watching. So guys, if you liked the video then please give it a thumbs up and please subscribe to the channel for upcoming videos.